Hi everybody, this is your video on complex fractions. So we just started this in class, so the video I'm going to start with the notes that you should have written down in your notebook. If they're not written down, pause now and write these please. This is just quickly summarizing the two methods that we have for simplifying complex fractions. Now a complex fraction is when you're going to have a fraction all over another fraction. And your goal is to turn it into just a normal fraction with one numerator, one denominator, not like a numerator denominator over another numerator denominator. You can choose whichever method you want to do. Method 1 uses dividing. Method 2 allows you to skip the dividing step through a little trick involving the LCD of every fraction. Method 1 is the only method I learned in high school. Method 2 I learned later, so I'm going to show you both methods for the example, and then you can choose which one you like better. So pause the video if you need to get these notes down, the introductory ones, so you have something to look back on. And let's start off with this example right here, which is going to look like this. So there's our first fraction. And there's our numerator up here has fractions, our denominator has fractions. We want to simplify the whole thing. Like I said, I'm going to do method 1 first here. And method 1 means that you completely ignore this denominator. So the denominator does not exist, and you're just looking at these two right here, and you're going to pick out the LCD of the numerator right here, those denominators. And since they share nothing in common, the LCD is just the product of their two denominators. Pretend that the numerator doesn't exist, and you're going to write down the LCD of the two fractions in your denominator. So those two denominators share nothing in common, so their LCD is the product of their two denominators. Now what I need to do, yellow denominators look like this yellow LCD, and make my blue denominators look like this blue LCD. So in order to make x plus 2 become 3 times x plus 2, I need a 3 here. And in order to make 3 look like my LCD, I need an x plus 2. Let's go ahead down here and rewrite that. 3 times 3 is 9, plus 2 times the quantity x plus 2. I can put this over the one LCD now, 3 parentheses x plus 2. All right, now let's take a look at these two. I have x plus 2, but I really want x plus 2. So let's multiply by x. Here I have an x, but I need x plus 2. So I'm going to multiply by x plus 2. And I'm going to put these two down here. So x times 2x is 2x squared. Minus 1 times x plus 2 is just minus the quantity x plus 2 all over the LCD down here. So let's clean up each of these. Again, this is my whole numerator, my whole denominator. So 9 plus 2x plus 4 all over 3. I'm not going to distribute the 3, and you'll see why momentarily. I'm going to distribute my negative like so. All right, so I have one big numerator divided by one big denominator. And we know that in order to divide two fractions, we're going to multiply by the reciprocal of the denominator. So let's go ahead and do that. Now, while I'm rewriting this numerator, let's go ahead and combine like terms here and make that a 13, 9 plus 4, plus 2x over 3x plus 2. Then I'm going to multiply it by the reciprocal of the denominator. So 2x squared minus x minus 2. And a wonderful thing will happen here. I'm canceling those two. That's going to simplify a little bit. So now I have 13 plus 2x all multiplied by x. I need those parentheses to indicate multiplying by x to this whole thing. Don't forget those parentheses. That's really important. Let's see, I have a 3 down here, and I have a 2x squared minus x minus 2. And we're done. If you were to factor this here, if you were to try to, nothing would cancel on the numerator, so you are good to go to leave it like that. Now let's do this same problem, method 2. So make sure you have method 1 written down, and I'm going to put method 2 below it, and you can compare them. 2, I'm going to look at all 4 of my denominators at the same time. I'm not pretending that part of the fraction doesn't exist. Everything is there, and I want the LCD of all 4 denominators here. So I see x plus 2 repeating here, so I only need to write that once. I see a 3, and I also see an x. So 3x plus 2x, that's going to be my LCD. So what I need to do is multiply everything by the LCD. So watch carefully here. 3x, x plus 2. I'm just rewriting the order. I want the x in front of the parentheses. So I'm going to multiply my whole numerator by my LCD and my whole denominator by my LCD. This is really over 1 here, just so you know. And something awesome is going to happen here when I multiply this by here and by here, and multiply this here and here. Now, the next step that I'm doing, you should only have to do once, and then you should be able to see the canceling in your head without needing to write this all out, because this is a little bit tedious writing this, but it does help a lot to see it at least once. So you'll see what I'm doing. I'm just rewriting my problem. And like I said, we're going to multiply this by every single term. So I'm going to multiply by 3x, x plus 2. I'm going to multiply by 3x, x plus 2. And then I'm going to multiply down here my two terms by 3x, x plus 2. And last one, 3x, x plus 2. Again, these are all over 1. Keep that in mind whenever you do this. So let's look at each one individually. I have these in the numerator and this in the denominator. You should see this canceling going on right here. This is my numerator, this is my denominator. 3's cancel. Down here, that's my whole numerator, that's my denominator. X plus 2 cancels here. And in my numerator and denominator, you should see an x canceling. Notice I just got rid of the denominator of all 4 of my little fractions here. And that is why I'm not going to have to divide, because watch what's left. I have 3 times 3x, 9x. And then right here, I have 2 times x plus 2. And then in the denominator here, I have 2x times 3x. So that would be 6x squared minus a 3 is left over and an x plus 2. Is I just did this 2 times x and wrote it nicer here so that I can distribute it easily and get 2x squared plus 4x. The very last thing you can do is add 9x and 4x and get 13x. And 6x squared minus 3x minus 6. So let's take a look at our two answers and see if we actually got the same thing. Here is the method 2 answer. Here was the method 1 answer. They are the same exact thing. If I just took out this x, I would get 13 plus 2x. If I took out a 3 from all 3 of those terms, I would end up with this right here. So we get the same thing either way. You can choose which one you'd like better. I'm going to do another example here, and then I'm going to give you one to try. Example right here, I'm going to do method 1 again first. Then I'll do method 2, and then after this point, you can choose which one you want to do for the example at the end. Just realize that 2 is over a 1. Okay, so let's just take a look at our numerator right now. I have 2x minus 1 and 1. The LCD of my numerator is 2x minus 1. Now my denominator, I have 4x and 2x minus 1. The LCD of my denominator is 4x, 2x minus 1, because I don't share anything in common. So let's take care of this first, and then we'll take care of that. We're going to completely treat them separately. So in the numerator here, I need to make each of these become that. Well, this one already is the LCD, so we're good to go. This one needs a 2x minus 1, top and bottom. Right here, let's take a look at that and make that our LCD. I have 4x, so I need 2x minus 1 on the top and bottom. And I need a 4x here. I already have the 2x minus 1. Okay, so let's rewrite this here. And the 3x is good to go. I have minus 2 times 2x minus 1. That's all over my LCD on the very top. Huge fraction bar. I have 5. And then 2x minus 1. I have minus, okay, x times 4x. I'm just going to make that 4x squared. It helps to simplify as you go. All right, so let's do some simplifying here and see what happens when all the dust settles. What I did is I distributed my 2 and I distributed my 5. So I get this step written down. So I have a huge numerator and a huge denominator. Let's actually divide those by multiplying by the reciprocal of the denominator. So what I'm going to do is just say, okay, 3x minus 4x negative x. Simplify as we go here. Multiply by the reciprocal. I'm not going to cancel because I'm anticipating, or I'm not distributing the 4x because I'm anticipating canceling. Wow, that was a struggle. Okay, anyway, 2x minus 1, I can see right away that's going to cancel. And I have a 4x on top. I have a negative x plus 2. And down here, 10x minus 5 minus 4x squared. I can think of to do to make this look a little nicer is just to distribute that. So negative 4x squared plus 8x. And let's write this in the standard form where we go in decreasing order of exponents. And there's our final answer. So let's see if we get this when we do method 2. All 4 of our denominators here, we want the LCD of everything. So our giant LCD here, let's see, 2x minus 1 repeats. So just put that once, and then I have a 4x, and then I have a 1, but 1's really irrelevant. So let's multiply our whole top by 4x, 2x minus 1, and our whole bottom by 4x, 2x minus 1. Now I am going to actually do this one more time. I know I said I would only do it once, but just so you can see one more time what really is going on here with the canceling. Again, the goal is that you can see this without actually needing to write this step. And I have a feeling that very soon, or maybe already right now, you would be able to do this without doing this step. So I have 2x minus 1 canceling. This was over 1, so there's nothing canceling there. 4x canceling, and 2x minus 1 canceling. All the denominators are gone, so let's see what's left in the numerator. I have 3 times 4x, well that's 12x. And an x the whole time. So just jump back real quick and put an x there. So that would be 3x times 4x, 12x squared. And then right here I have minus, I'm going to do 2 times 4x and get 8x. And then 2x minus 1. All over 5 is left. 2x minus 1 is left, minus x times 4x, well that's 4x squared. Okay, let's clean this up a little bit. That would be minus 16x squared plus 8x, all over 10x minus 5 minus 4x squared. I just distributed the 5 down there. Okay, 12x squared minus 16x squared, that's negative 4x squared. This looks familiar, that's good, plus 8x. Negative 4x squared plus 10x minus 5. Okay, awesome. We got the same thing. I'm going to give you a you-try problem, and you can do this either method that you want, and then in class we're going to compare what you got. So at the end of your notes, let's give this a try. Okay, 6 over x minus 5 plus 1 over x, all over 3 over x minus 2 over x minus 5. Pick either method, doesn't matter. I'm actually going to put the final answer so that you know what you're looking for, because it's nice to know if you did it right whenever you actually do the problem out. There's your final answer. Now you can do those 3 problems at the end of the half sheet. There were 3 complex fractions on your A, B, or C. So do this, you try and do those 3, and I will see you in class. Good luck on your AP exams. Bye.